Hello, it's Keith here, and this is the second of the so-called MinTile series of my 6502 assembly programming tutorials. What's MinTile apart from being hard to pronounce? Well, it's my minimum tile map drawing routine. So we've got this example here. This is the PC Engine version, but there's an equivalent version on all of the systems in my tutorials for the Z80, 6502 and 68000. So we can have objects move around the screen, we can scroll the background, and we've got X flipping. We don't have Y flipping on this version. Now, this is the PC Engine, so it has hardware tile map, but this also works on bitmap based systems like the C64 and the BBC. So it's a multi-platform system. Now, I described the Chibico character as an object rather than a sprite because the engine doesn't use hardware sprites, it uses the same tile map code. So in the case of the PC Engine, the software, the tile map is used to draw the so-called sprite objects, not the hardware sprites. That's because this is a very simple, minimalistic tile map code, hence Mintile. So rather limited there. Anyway, let's go over to the source code. Let's take a look. Okay. So the first thing we're going to discuss is the flag sprite for refresh function. Now, we don't want to redraw more than we need, so we've got flags on our objects to redraw them. Now, we set the 0-page IX pair to the memory address of our sprite object, and this has a variety of entries: the pointer to the tile map, the pointer to the patterns, the width and the height in logical units, the X and Y pos in logical units, and some flags for whether the tile map underneath it needs to be redrawn and whether the sprite itself needs to be redrawn. We also have the old X and Y pos for when the sprite moves around so that we know where the old position was. Now, those are the parameters we've got here. So the first thing we might need to do is we might need to redraw our sprite, and we need to set it, flag it that it needs to be redrawn. So in that case, we're going to set the refresh tile to redraw the background and the refresh sprite to redraw the sprite itself. Now, when we're asked to draw the sprite as part of our loop, the first thing we want to do is we want to check if the refresh sprite flag is set, and if it's not, we're simply going to return here. So that's what we would do there. If it was set though, we're going to clear it, and then we're going to actually start the draw. So we're going to load in the parameters of the sprite that we want to draw. So we're loading in firstly the tile map. Now, sprite objects, as I say, aren't true hardware sprites, even on systems that support hardware sprites. They are actually a miniature tile map. So if we look at this PC Engine version here is the tile map for the background graphics. And here is this tiny little tile map for the Chibico character. That is our Chibico character in tiles, and the tiles will be offset from the patterns of the Chibico character that have been loaded into VRAM on the PC Engine. So that is the tile map we're loading in here. We're loading in the X and Y pos, and we're backing those up so that we know where the sprite was if it's going to move. We are then loading in the pattern data. Now, on a system like the PC Engine, that would be a pointer to the first tile number that makes up the Chibico character. So if you look at the PC Engine, for example, tile 1 of the Chibico character and tile 1 of the tile map are not necessarily the same tile, because the pattern offset within the pattern definitions or within the bitmap data will be defined by these entries here. Now, we're loading in the flags here, and the bottom bit is the X flip flag. There is no Y flip on this version of the code. Didn't have time to code that into all of the systems. This engine was designed as a little test and to write my little chibi fighter sort of test game, and that only needed X flips, so that's all I've done in this case. We are then loading in the width here, storing that in D, loading the height, storing that in E, and then we're swapping those over so they're actually in H and L now. And then what we're going to do next is we're getting our flags. We want the X flip parameter, and we're then running our DoCrop routine. Now, DoCrop we're going to look at in a moment. That is similar to the version that we had before in the simple series. This is going to crop the sprite, because if our object, if we've got our character here, and if it's partially off the screen, we're going to need to remove the partially off screen parts and not attempt to draw them. And that's what DoCrop will do. And it will set the carry if the sprite object is completely off the screen. Now, we're then going to return. Now, DoCrop, as with the simple series, works in logical units, which means pairs of pixels. Now, we want to convert that into tiles, which means blocks of 8 by 8 pixels. And so we simply divide the width and height by 4 here. We're then going to run the get screen pos routine, which is a platform specific routine to get the memory address of the XY position in logical units that we want to draw to. Now, that's platform specific, so there'll be a version on each system depending on the VRAM coordinates of that system, but it will pass a usable value there. And then what we're doing here is we are setting up our tile source address into DE, and we are setting up our tile width here. It's been loaded from A, but it was being pushed up here. It was being loaded in there, so that's the width. That's the native width before the cropping, because the cropping might change the width that we want to draw, but the original width is still the same, and we need to know that because we need to actually skip. Once we've drawn a line, we need to skip down to the next width, the next line. Okay, and then what we're going to do basically is we're either going to run draw tilemap or draw tilemap reversed, depending on if the xflip is in play there, and draw tilemap reversed. And we looked at both of those last time, so if you need to see how they work and how they draw the tilemaps to the screen, please see the first episode in this series. Okay, so that's the draw tilemap and the sprite drawing routine. What we're going to look at next is the DoCrop routine, which is mostly the same as the one in the simple series. And so if you've seen the simple series, you may want to skip out at this point because there's not a whole lot new to see. Now, a few other things though. Firstly, what we're doing here is we're checking the xflip flag. Now, if the xflip isn't set, we're just simply going to skip down here and start doing the crop. If the xflip is set though, then what we're basically going to do is we're going to recalculate the coordinates, effectively flipping the sprite to the other side of the screen, because the DoCrop routine and the way the sprites are drawn to the screen won't work correctly. It won't provide the correct values to the other routines if we don't basically trick it into giving us them. So what we're going to do is we're effectively going to flip our sprite to the other side of the screen here. And so that's what we're going to do here. So what we're doing here is we are adding the width of our sprite to the X position here, and we're then going to do our crop with the main routine, and then what we're going to do is we're going to subtract that result from the width of the screen here. And so that is effectively sort of flipping our sprite to the side of the screen and then flipping it back, and that is so that it gives us the correct mathematical values for the crop based on the fact that the sprite is actually pointing in the opposite direction. Now, this is the MinTile basic routine. I'm planning a max tile routine, which is an improved version with a lot of improvements and corrections for the limitations of this version, and this is one of the things that is kind of a limitation, that I had to basically trick the routines into providing the correct values that I needed. Okay, so let's take a look at the main body of the DoCrop routine. And as I say, if you've seen the simple series, you're probably going to recognize it because it's very similar. Now, during these routines, we use the D&D 0-page entries as temporary variables. So we're going to load those with 0, and Y is going to be loaded with 0, and Y stays 0 throughout this routine. Okay, so what we're going to do is basically take our sprite's position in logical units, and we're going to consider it for the corners of the screen and crop the sprite accordingly, and calculate if the sprite is off the top or the left, we're going to need to skip some tiles of our source tile map, and so we're going to do that as well. So the first thing we're going to do here is we're going to load the Y position of our sprite in logical units, and we're going to subtract the address, the value of the first minimum logical unit that's visible on the screen. So that's basically going to nudge the value of our position up, and so if it's partially off the screen, that is now going to go negative. If it doesn't go negative though, we are entirely on the screen and we can skip the next stage. But if it has, we're going to convert that back to a positive by running this neg routine. We're going to then add 2, and that is to round up, because that's half a tile basically. And then we're going to then compare to the height of our sprite, and if the resulting value is the entire height of our sprite, we must be entirely off the screen. And in that case, we're going to go to the all off screen routine. And what does the all off screen routine do? Well, it simply sets the carry and returns, because the calling routine will check that carry and give up if it's set. Okay, so we've now calculated basically the amount of tiles we need to remove from the top. But if we're partially off the screen, well, maybe we need to remove a full tile because we're working tiles. But if we are allowing for partial tile movements, we want to basically draw the remaining part half a tile down on bitmap systems that can do that. And so we need to calculate the shift for the bitmap part that we're going to draw. And so what we're doing is we're taking the fractional tile part here and we're EORing it to get that Y offset there. Whatever happens though, we are now updating the C value, the Y position, because if we didn't do any cropping, we at least subtracting the minimum Y position that is visible on the screen. What we're going to do now is the same for the bottom of the screen. So we're now going to add the height of the sprite, and this is basically checking if we're in a position like this, and then we're going to subtract the entire height of the screen basically. And if that's gone below 0, then basically there is nothing to crop. But if it hasn't, we must be partially off the bottom of the screen, somewhere like this. And so what we're going to do is we're going to calculate the number of tiles we need to remove, compare that to the height. If it's the entire height, we're off the screen. Otherwise, that's the amount we need to remove from the bottom. Okay, we've got the amount to remove from the top, the amount to remove from the bottom. So what we're going to do here is we're going to convert those to tiles, add them together, and then we are going to basically see if that is nothing. If it's not, we're going to convert that to a negative value, and we're going to add it to the height. So this is calculating the new height. And what we're then going to do is we're going to look at the E part, which is the amount to remove from the top, because we need to now skip any tiles that shouldn't be drawn. Source tile map is in IY, and so what we're going to do is we're going to calculate the number of tiles per line. That's the width converting to a number of tiles, and we're going to use the number of lines, and we're going to subtract that from the IY pair here, the IYHL pair here. Okay, so we've done the top and the bottom. We're now going to do the left and the right. So basically what we're going to do now is we're going to take the X position, we're going to subtract the minimum visible X position. If that has not gone below 0, then we aren't off the left-hand side of the screen, so we can just skip. Otherwise, we convert back to a positive, round up to a number of tiles compared to the width. If that is greater than the width, then we are entirely off the screen, and so we would go to all off screen in that case. Otherwise, we only need a partial crop, so we're storing that partial crop in E, and we're then calculating the X offset for the tiles that we're going to draw in the exact same way as we did with the Y position. Now, what we're going to do then is we are going to basically store the updated value in XPOS. That's not in the right position there. That should be here. So that's what we're doing there. And then what we're going to do is we're going to add the width, and we're then going to basically subtract the entire width of the visible screen. If that's gone below 0, then we're entirely on the screen, so we don't need to do any cropping. Otherwise, we check if that's the entire width of the sprite, and if it is, then we're entirely off the screen. Otherwise, that's the amount to remove from the right. We're then adding the amount to remove from the left and the amount to remove from the right, converting them to a number of tiles. If that goes below 0, if that's 0, then we're just giving up. Otherwise, we are negating that and storing it to H here. H and L are currently still calculated in logical units, not tiles, but we will convert them later. And basically, again, if our width is now entirely 0, once it's been converted, rounded to tiles, then we're going to give up. Otherwise, we're storing the new width. Then what we're going to do is we are going to take the amount to remove from the left, convert that to a number of tiles, and basically again, if we're off the left hand side and that fireball there was the first tile, well, maybe we need to skip it. And so that's what we're going to do here. So we're going to add the E part in tiles to the IY pair here, which is the source tile data. We're now finished, so what we do is we clear the carry and we return. And finally here we've got a neg command here for negating a value in the accumulator there. So just a useful function there. And there we go. So that is actually all we're going to be covering today. If you like what you've seen, please like and subscribe. We've got loads more of these tutorials coming. We're going to go through the remainder of the Mintile code and the actual tile drawing routines for each system. So please stick around for that. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching and goodbye.